Welcome to Hypothesis Testing Population Proportion. This is the book I'm referring to. You could buy this book if you want, or you should have any other book while you're referring to the tutorials. It's always good to have a book on statistics so that you can have your concepts cleared. It's always good to have a supplementary or a complementary material with you. When we look at hypothesis testing for population proportion, you have P. What is the population proportion? So usually the population proportion is not known, and hypothesized population proportion. So this will be given as P0 and the sample proportion. So you will have a sample size, and from there you're deriving a sample proportion, which is given by P bar. For population proportion is exactly what we have done before, except the formulas change. We are going to be calculating test statistic. When we are looking at standard error of P bar, which is what we are getting from the sample, which is we call sample proportion, is given by the following formula. We'll apply these rules in a numerical to see how to solve a population proportion. It's exactly very similar to what we have done before. We'll look at null and alternative hypothesis. Then we are going to be using this Z statistic, and we'll be calculating the standard error of sample proportion. The null and alternative hypothesis, this is something which I have already talked about. You could have a single tail test, or you can have a two tail test. Tail test, upper tail test. Talking about upper tail test, I'm talking about the p-values here. So p-value is now given for alpha. When you're looking at a two-tail test, get alpha on both the sides. So this alpha is level of significance. Here you had 46% of business owners who have come to know this year it seems 35% plan to provide holiday gift to the employees. We know the sample proportion is 0.35, so 35% will be 30 whenever you are taking 0.35, 35. Now when we are looking at the hypothesized population proportion, we are given as, but the question here is how many business owners in the survey plan to provide a holiday gift to their employees this year. So this year figures is 0.35 and you have the sample as 60. Business owners this year who want to provide a holiday gift to their employees this year. Question: we are looking at how many. This is the where you will be doing the hypothesis testing. You want to compute the p-value of a hypothesis test that can be used to determine the population proportion of the business owners providing holiday gifts has decreased from the last year. Clear hint. So that's why I've underlined this as decreased. This testing would be null. What you get from the question has decreased. So this is what you want to test, whether it has decreased or not. What you do is you'll calculate the standard error. Standard error for sample proportion. We put in the values. We have already got the value of P0, which we have shown is 0.46. From the sample we got 0.35, which is what we are substituting. P bar is the sample proportion minus the hypothesized population proportion. Now that is given as 0.46. We divided by so once we get the value of Z, we are going to use and 1. Now 0.044 when you're taking the p-value. Now p-value when you're looking at the smallest value to reject the null hypothesis, which is 0.0 0.05 level of significance, which is 5%, which I talked about. Now you're looking at the p-value. Now the p-value is less than 0.05, so you can reject the null. The question is, would you conclude the proportion of business owners providing gifts decreased? Yes, level it is. But what is the smallest level of significance for which you could draw such a conclusion? It will be 0.05 only, because at 0.01 the p-value is actually greater than 0.01, so you cannot reject the null. Is the smallest level, it will be 0.05, which is the level of significance.